What's going on, guys? It's your boy Izma coming back to you with another Try Hack Me challenge. And today on my new project, I am working on a Burp Suite Other modules. And it says take a dive into some of Burp Suite's lesser known modules. Task 1 Introduction. Welcome to the Burp Suite Other modules room. In addition to the widely recognized repeater and intruder rooms, Burp Suite incorporates several lesser-known modules. These will form the focus of this room's exploration. The spotlight will be on decoder, comparer, sequencer, and organizer tools. They facilitate operations with encoded text, enable comparisons of data sets, allow the analysis of randomness with captured tokens, and help you store and annotate copies of HTTP messages that you may want to revisit later. Although these tasks appear straightforward, accomplishing them with Burp Suite can substantially save time, thus emphasizing the importance of learning to use these modules effectively. Without further ado, let's delve into the first tool, the decoder. Answer the question below. Deploy the machine attached to the task by pressing the green Start Machine button as well as the attack box, using the Start Attack Box button at the top of the page if you are not using your own machine. So now let's start the attack box and also start the machine. And just like that, we are in. And now let's click complete. And this part is completed. Moving on to task 2, decoder overview. The decoder module on Burp Suite gives us users data manipulation capabilities. As implied by its name, it's not only decodes data intercepted during an attack, but also provides the function to encode our own data, prepping it for its transmission to the target. Decoder also allows us to create hash sums of data, as well as providing a smart decode feature, which attempts to decode provided data recursively until it is back to being plain text, like the magic function of Cyber Chef. To access the decoder, navigate to Decoder tab from the top menu to view the available options. So basically, you open up Burp Suite and you go on decoder. Moving on, this interface lays out a multitude of options. Number 1, this box serves as the workspace for entering or pasting data that requires encoding or decoding. Consistent with other modules of Burp Suite, data can be moved to this area from different parts of the framework via the Send to Decoder option upon right-clicking. It is speaking about this section right here, as you can see. At the top of the list on the right, there is an option to treat the input as either text or hexadecimal byte values. And that is talking about number 2 right here. Moving on to 3, as we move down the list, drop-down menus are present to encode, decode, or hash the input, and that's this part right here. Moving on to 4, the smart decode feature located at the end attempts to auto-decode the input, and that's right here. Upon entering data into the input field, the interface replicates itself to present the output of our operation. We can then choose to apply further transformations using the same options. Moving on to answer the question below, which feature attempts to auto-decode of the input? And that's smart decode. And there you have it for this part of the section. Moving on to task 3, decoder, encoding and decoding. Encoding and decoding with decoder. Now let's examine the manual encoding and decoding options in detail. These are identical whether the decoding or encoding menu is chosen. Plain, this refers to the raw text before any transformation are applied. URL. URL encoding is utilized to ensure that the safe transfer of the data in the URL of a web request. It involves substituting characters for their ASCII character code in hexadecimal format, preceded by a percentage symbol. This method is vital for any type of web application testing. For instance, encoding the / character whose ASCII character code is 47 converts into 2F in a hexadecimal, thus becoming 2% 2F in URL encoding. The decoder can be used to verify this by typing a / in the input box, then selecting encode as URL. So we're going to go ahead and try that. We're going to use the encode. We're going to put that as URL, and as you could see, it's a 2% 2F. Moving on, HTML. HTML entities encoding replaces special characters with an ampersand and followed by either a hexadecimal number or a reference to the character being escaped, ending with a semicolon. This method ensures the safe rendering of special characters in HTML and helps prevent attacks such as XSS. The HTML option in decoder allows any character to be encoded into its HTML escape format or decode captured HTML entities. For instance, to decode a previously discussed quotation mark and input the encode version and choose the decode HTML. Base64. Base64 commonly used encoding method converts any data into an ASCII compatible format. The under the hood function is crucial at this stage. However, interested individuals can find the underlying mathematics here. ASCII hex. This option transition data between the ASCII hexadecimal representations. For instance, the word ASCII can be converted into the hexadecimal number 4153434949. Each character is converted from its numeric ASCII representation into hexadecimal. Hex, octal, and binary. These encoding methods apply solely to numeric inputs, converting between decimal, hexadecimal, octal, base 8, and binary representation. gzip. gzip compresses data, reducing file and page sizes before browser transmissions. Faster load times are highly desirable for developers looking to enhance their SEO score and avoid user inconvenience. Decoder facilitates the manual encoding and decoding of gzip data, although it is often invalid. ASCII Unicode, for instance. Let's just take a see what they are talking about right here on their example. Moving on, these methods can be stacked. For example, a phrase Burp Suite decoder could be converted into ASCII hex and then into octal. So let's see what they're doing right here in the GIF. As you can see, they started with the burp sweep. Now they switched it into the encode. And now, what? So they did it. They encoded this 2 times. Moving on. In combination, these methods grant us substantial control over the data we are encoding or decoding. Each encoding decoding method is color coded. enabling swift identification of the applied transformation. Hex format. While inputting data in ASCII format is beneficial, there are sometimes when byte by byte input editing is necessary. This is where hex view proves useful, selectable above the decoding options. And the GIF is just showing you an example of what it's talking about. This feature enables us to view and alter our data in hexadecimal byte format, a vital tool when working with binary files or other non-ASCII data. Smart decode. Lastly, we have the smart decode option. This feature tries to auto decode encode text. For instance, this right here, they put it in here, is automatically recognized as HTML and coded and accordingly decoded. And it is just showing us how it did it. After it did smart decode, it went into Burp Suite. While not perfect, this feature can be a quick solution for decoding an unknown data chunks. Moving on to answer the questions below. So now for our task, we have base64 encode the phrase, let's start simple. What is the base64 encoded version of this text? So this is a pretty simple task. So we're going to copy paste, put it on there. Let's make sure we remove that. And now we have to encode it into base64. And there you have it. Copy paste this and you should get the answer, and click the green button. Moving on, URL decode this data. What is it in plain text return? So now basically you have to copy paste this. Now let's decode this data into URL. And there you have it. That's the answer. Go ahead and put it in there. Moving on. Use smart decode to decode this data. What is the decoded text? So we'll try it. So we are using smart decode. There you have it. It's 47. Moving on to the encoding phrase encoding challenge. Start with base64 encoding. So we're gonna copy paste this. We're gonna start with base64 encode. Take the output of this and convert it into ASCII hex. So now we're gonna do this. Finally, encode the hex string into octal. So now we have to encode this into octal. And there you have it. That's the answer. Just go ahead and copy paste that and click the green button, and you're set to move on to the next step. Moving on to task 4, decoder hashing. Hash, in addition to its encoding decoding functionality, decoder also offers the availability to generate hash sum for our data. Theory. Hashing is one-way process that transforms data into a unique signature for a function to qualify as a hashing algorithm. The output is generates must be irreversible. A proficient hashing algorithm ensures that every data input will generate a completely unique hash. For instance, using MD5 algorithm to produce a hash sum for the text MD5 sum returns this right here. Using the same algorithm for MD5 sum yields an entirely different hash despite the close resemblance of the input.
which reflects at this number right here. Therefore, hashes are commonly used to verify the integrity of files and documents, as even a tiny alteration to the file significantly changes the hash sum. Note, the MD5 algorithm is depreciated and should not be used for contemporary applications. Moreover, hashes are used to securely store passwords, since the one-way hashing process makes the passwords relatively secure. Even if the database is compromised, when a user creates a password, the application hashes and stores it. During login, the application hashes the submitted passwords and compares it against the stored hash. If the password is correct, using this method, an application never needs to store the original plain text password. Hashing and decoder. Decoder allows us to create a hash sum for the data directly within Burp Suite. It operates similarly to the encoding/decoding options we discussed earlier. Specifically, we click on hash drop-down menu and select an algorithm from this list, which is this right here. Note, this list is significantly longer than the encoding/decoding algorithms. It's worth scrolling through to see the many available hashing algorithms. Continuing with our earlier example, let's enter MD5 sum into the input box, then scroll down the list until we find MD5. Applying this automatically takes us into the hex view. So let's go ahead and type that in. And that's the result that we get. A hashing algorithm output does not yield pure ASCII Unicode text. Hence, it's customary to convert the algorithm output into a hexadecimal string. This is the hash form you might be familiar with. Let's complete this by applying an ASCII hex encoding to the hash sum to create the neat hex string from our initial example. So now we go in here and we add this, and voila. I'm sorry, I actually did that wrong. So it would seem to put MD5 sum. Now we're scrolling into hash. MD5. And now we're gonna put it in. We're gonna put this in, and there you go. That's what should populate on there. Yep, just like the example. Moving on. Using decoder, what is the SHA/256 hash sum of the phrase "let's get hashing"? Convert this into an ASCII hex string for the answer to the question. So now we're gonna copy paste this. Now we're gonna put SHA-256. Now we're gonna encode as this right here, and there you go. Put that into this answer box and click the green button. Moving forward. Generate an MD4 hash sum of the phrase of the phrase insecure algorithm. Encode this as base64, not ASCII hex before submitting. Let's go ahead and do that. Sorry about that, I gotta delete that. Control V. So now this is an MD4. And now we'll encode it as base64 for our final answer. So go ahead and put that in there and click the green button, and we're set to go. Now let's look at an in-context example. First, download the file attached to this task, which would be this right here, this download task file, or you could do something else. Note, this file can also be downloaded from the deployed virtual machine with the WG, this right here, this link. You may find this helpful if you are using a attack box. So basically, I already did it, so I'm not gonna do it, but I'll show you what I did. So Control C this right here. Go into your terminal. I'm gonna copy paste this. I'm sorry. Paste that. Then you would hit enter. So now read the problem specifically below. Some joker has messed with my SSH key. There are 4 keys in the directory and I have no idea which is the real one. The MD5 hash sum for my key is this right here. Could you find it for me? What is the correct key? So how to do this is very simple. So basically you'd go into you'd go here in your root directory, and in theory this is what you could do. You could go to the first key. You're gonna copy and paste all of this into the directory. I'm sorry, not the directory. I meant the decoder. So copy paste that into the decoder. So you would do MD5. And there it is, MD5. Now you would encode this as ASCII hex, and it would be that. But I was doing some research, and I found a simpler way to do it if you don't want to go through all of them, which would be going to the terminal, putting ls here. Now you'd put, what was it? It was then you would put CV, I believe, keys. You just type in keys, right?
Now we're moving on to task 5, compare overview. Compare, as the name implies, lets us compare 2 pieces of data either by ASCII words or by bytes. Let's first check out the interface. The interface can be divided into 3 main sections. So here are the 3 main sections that we'll be talking about. So here's 1, 2, and 3, just as shown in the gift. The interface can be divided into 3 main sections. On the left, we see the items to be compared. When we load data into compare, it appears as rows in the tables. We select 2 data sets to compare. On the upper right, we have options for paste data from the clipboard, loading data from a file load, removing the current row, and clearing all data set clear. Lastly, On the lower right, we can choose to compare our data set either by words or by bytes. It doesn't matter which of these buttons you select initially because this can be changed later. These are all buttons we click when we're ready to compare, then select data. Just like most Burp Suite modules, we can also load data into compare from other modules by right clicking and choosing send to compare. Once we've added at least two data sets to compare and press on either words or bytes, a pop-up window shows us the comparison. And right here on the GIF, it is showing us an example of what it's talking about. Moving on. This window also has three distinct sections. The compared data occupies most of the window. It can be viewed in either the text or hex format. The initial format depends on whether we choose to compare by words or bytes in the previous window, but this can be overridden by using buttons above the comparison boxes. Number 2. The comparison key is at the bottom left, showing which colors represent modified, deleted, and added data between the two datasets. Number 3. Sync views box views checkbox is at the bottom right of the window. When the selected, it ensures that both sets of data will sync formats. In other words, if you change one of them into hex view, the other will adjust to match. The window title displays the total number of differences found. Once again, this is what we were talking about. Moving on for the answer to the question below, there is nothing to be answered, so you could just go ahead and move on to the next section. Moving on to task 6, compare example. We know what compare does, but how is this useful? There are many situations where being able to quick compare two potentially very large pieces of data can come in handy. For example, when performing a login brute force or credential stuffing attack. With Intruder, you may wish to compare two responses with different lengths to see where the difference lie and whether the difference indicate a successful login. Practical example, navigate to HTTP, this URL right here. Try to log in with an invalid username and password. Capture the request in the Burp proxy. So let's make sure this is off. Let's open a browser. Now we're going to copy and paste this right here. So now we're just going to put whatever information in. Type that in. Now we're going to make sure that the interception's off so it captures the request. Hit login. Let's go back into Burp Suite now. Alright, so we captured something. So now we have to send the request to repeater with Control R or Mac equivalent by the right clicking the request in the proxy module and choosing send to repeater. Send the request, then right click on the response and choose to send to compare. So we will go now to repeater. Make sure this went to repeater. Alright, so now we have to make sure, I'm sorry about that, send, and then the response goes into comparer. In the repeater tab, change the credentials to username support/admin and password to W58W capital S capital K 4W. Send the request again to then pass a new response to compare. So now let's check this out. Let's go to the request. Let's delete that and put the new one in. Support on slash admin. And now let's go ahead and send it. Compare the two responses by word. Can you identify the main difference? Let's compare them now. Now, so you could see, this is the main differences right here. And that just about much wraps it up for this one. Now just go ahead and click complete, and you are ready to move to the next section. Moving on to task 7, sequencer overview. Sequencer allows us to evaluate the entropy or randomness of tokens. Tokens are strings used to identify something and should ideally be generated in a cryptographically secure manner. These tokens could be sessions cookies or cross-site request forgery. CSRF tokens used to protect form submissions. If these tokens are generated securely, then in theory we could predict upcoming token values. The implications could be substantial. For instance, if the token in question is used for password resets. Let's start by looking at the sequencer interface. And we currently already have it open, but that's the GIF, so it's this right here, this tab. We have two main ways to perform token analysis with sequencer. Live capture. This is the more common method and is the default subtab for sequencer. Live capture lets us pass a request that will generate a token to sequencer for analysis. For instance, we might want to pass a post request to a login endpoint to sequencer, knowing that the server will respond with a cookie. With the request passed in, we can instruct sequencer to start a live capture. It will then automatically make the same request thousands of times, storing the generated token samples for analysis. After collecting enough samples, we stop the sequencer and allow it to analyze the captured tokens. Next one is manual load. This allows us to load a list of pre-generated token samples directly into sequencer for analysis. Using manual load means we don't need to make thousands of requests to our target, which can be noisy and resource intensive. However, it does require that we have a large list of pre-generated tokens. We will be focusing on live captures in this room. Now moving on to the answer the question below. What does sequencer allow us to evaluate? And that's the entropy. And just type that in there and click the green button and you're off. You're set to move on to the next chapter. Moving on to task 8, sequencer live capture. Great. Let's dive into the process of using sequencer live capture for the entropy analysis of the anti-brute force token used in the admin login form. First, capture the request to this URL. So make sure this is off. I'm going to open a browser. Now I'm gonna copy paste. I'm sorry. That's not it. So I have to copy paste this right here. So I'm not gonna bother reading too much of it. You could go read it through yourself. But I'm gonna just show you the overall what you have to do. So I'm gonna just type in whatever. I'm gonna go back into Burp Suite, turn on intercept, log in. So now now we're moving on to this portion of it. I'm sorry, we're actually moving to this part. So now you're gonna send this to sequencer. So from here you should click form field, but however mine's is not letting me. So for this step, all you will have to do is click on form field, and after that you're gonna put start live capture, and from there it's gonna go to this part. It's gonna a new page is gonna go up. Basically, you let it run until you hit 10,000 tokens. Then you press pause. Then you hit analyze, and then something like this is gonna pop up, and it's gonna show you this whole process, the summary, right? So moving on. For the answer to the question below, what is the overall quality of randomness estimated to be? And that's excellent. And from there you can move on to the next chapter. Moving on to task 9, sequencer analysis. Now that we have a report for the entropy analysis of our token, it's time to analyze it. To generate entropy analysis report is split into 4 primary sections. The first of these is a summary of the result. The summary gives us the following. Overall result. This gives us a broad assessment of the security of the token. Generation mechanism. In this case, the level of entropy indicates the tokens are likely securely generated. Effective entropy. This measures the randomness of the tokens. The effective entropy of 117 bits is relatively high, indicating that the tokens are sufficiently random and therefore secure against predictions of brute force attacks. Reliability. The significance level of 1% implies that there is 99% confidence in the accuracy of the result. This level of confidence is quite high, providing assurance in the accuracy of the effective entropy estimation. Sample. This provides details about the token samples analyzed during the entropy testing process, including the number of tokens and their characteristics. While the summary report often provides enough information to assess the security of the token's generation process, it's important to remember that further investigation may be necessary in some cases. The character level and byte level analysis can provide more detailed insight into randomness of tokens, especially when the summary result raise potential concerns. While the entropy report can provide a strong indicator of the security of the token generation mechanism, there needs to be more definitive proof. Other factors could also impact security of the tokens and the nature of the probability. And statistics means that there's always a degree of uncertainty. That said, an effective entropy of 117 bits with a significance level of 1% suggests a robustly secure token generation process. For the answer question below, there is no answer needed. Moving on to task 10, Organizer Overview. The Organizer module of Burp Suite is designated to help you store and annotate copies of HTTP requests that you may want to revisit later. This tool can be particularly useful for organizing your penetration testing workflow. Here are some of its key features. You can store requests that you want to investigate later. Save requests that you've already identified as interesting, or save requests that you want to add to a report later. You can send HTTP requests to Burp Organizer from the other Burp modules, such as proxy or repeater. You can do this by right-clicking the request and selecting the organizer, or using the default hotkey Control O. Each HTTP request that you send to Organizer is a read-only copy of the original request, saved at the point you sent it to the Organizer. Requests are stored in a table which contains columns such as request index numbers, the time the request was made, workflow status, burp tool that the request was sent from, HTTP method, server hostname, URL file, path, URL query string, number of parameters in the request, HTTP status code of the response, length of the response in bytes, and any notes that you have made. To view the request and response, click on Organizer item. Then the request and response are both read only. You can search within the request or the response. Select the request and then use the search bar below the request. For the answer to the question below, are saved requests read only? Yay or nay? And that's yeah. Congratulations on completing the Burp Suite Other modules room. To summarize, Decoder allows you to encode and decode data, making it easier to read and understand the information being transferred. Comparer enables you to spot differences between two data sets, which can be pivotal in identifying vulnerabilities or anomalies. Sequencer helps in performing entropy analysis on tokens, providing insights into the randomness of their generation and consequently their security level. Organizer enables you to store and annotate copies of HTTP requests that you may want to revisit later. Having a fundamental understanding of these tools equips you with a broader skill set when it comes to web application penetration testing. In the next and final room of this module, you will be exploring Burp Suite extension tool. For the answer question below, I understand how to use Organizer, Decoder, and Sequencer and Compare. And just go ahead and click the green button and you're all done with this